Hi, today we're going to be learning about rotations, which is part of the transformation geometry section. Before we start, I just want to quickly remind you that when we are transforming points and shapes, the image of point A after a transformation is called A prime. So anytime you have any point that is being transformed in any way, you can have it translated or reflected, as we've already learned about before. Today we're going to be learning about rotations. That point is going to change from whatever it is, so it could be A, and then it'll become A prime, or if it's B, it'll become B prime, and so on. Okay, so now let's go on to rotating points on the Cartesian plane. We can rotate or turn a point on the Cartesian plane. There are three parts to a rotation transformation that we need to be aware of. The first one is the center of the rotation. It's usually the origin, but it can be other points. But what we're going to be working with is rotating points around the origin. There's also a direction for the rotation that you need to be aware of. It can be clockwise, which is going in this direction, the same as the numbers on a clock, or the direction that the hands move on a clock. Or it can be anti-clockwise, which is in the opposite direction. Okay, so you need to be aware of the center of the rotation, which will for us be the origin, and the direction of the rotation, and then also the angle of the rotation. It will usually be 90 degrees, which is a quarter turn, or 180 degrees, which is a half turn. Okay, you can do other rotations as well, or other angles, but these are the ones we are going to be doing. Right, let's have a look at our first example for today. The point B, 3, 6, is rotated about the origin. Write down the coordinates of B1 after rotating B 90 degrees clockwise, B2 after rotating B 90 degrees anti-clockwise, and B3 after rotating B 180 degrees. Okay, now first of all, I just said to you that when you do a transformation to a point, it becomes, so in this case it would be B prime. But when you're doing more than one transformation to the same point, we don't call them all B prime, because then you're going to have different points that all have the same label. So that's why these are being called B1, B2, and B3. Okay, so don't get worried about the fact that it's now not B prime. It just is, we're doing this because we have more than one point that are the result of taking the same point over here and transforming it in different ways. We are rotating it in different ways, and so we're ending up with different points. Okay, so that's just so we can differentiate between them, B1, B2, and B3. Right, so let's have a look at how we would do this. The very first thing we need to do, obviously, is plot the point that we're starting with. We are starting with a point B, which has the coordinates 3, 6. So it's over here, 3, 6. So here's our point B. Okay, the next thing we need to do is we need to know where the center of our rotation is. Now, like I said, we are going to be doing rotations where the center is the origin. So that's going to be over here. Now, when you're doing this, what I want you to do is I want you to put your finger on the center, and I want you to rotate your page in the direction and for the angle of the rotation. So the first one we're doing is B1. So we're going to be rotating 90 degrees clockwise. So you're going to put your finger on the center of the, or on the origin, and we're going to rotate the page 90 degrees in a clockwise direction, and we're going to end up with this. Okay, so now your page should look something like this if you've plotted the point and you've done what I said. Now I want you to pretend that we didn't rotate anything in terms of the axes. The axes I want you to think of as though we hadn't rotated them. You should still be thinking of them as this is the x-axis, this is the y-axis, okay? And I want you to have a look at where this point is now in relation to where the axes normally would be. So if this is the x-axis, this is the y-axis, look at where this point is. It has got the coordinates 6 minus 3. Okay, so that is what our point will be after it has been rotated by 90 degrees in a clockwise direction. So now let's go and put it back again. We're going to put a point in that position. So I'm going to go and rotate the page back again to how it was to start with. And now we're going to go and put a point in that position. So it had the coordinates 6 minus 3. So this is going to be our point over here. So B1 is what we get after rotating B 90 degrees clockwise around the origin. Okay, so B1 has the coordinates 6 minus 3. Okay, so now let's go on to B2. To find the coordinates of B2, we need to rotate B 90 degrees in an anti-clockwise direction. So now, again, I want you to put your finger on the origin because that's the center of our rotation. And you're going to rotate your page, but this time you're going 90 degrees or a quarter turn in anti-clockwise direction, so this way. And now let's have a look at where the point B is. If our axes haven't changed, if they are still normal, then this would have the coordinates -6, 3. So that's where the point B ends up after a rotation of 90 degrees in the anti-clockwise direction. Okay, so now let's go and put it back again. So we're going to go and rotate this back to where it was. And we're going to put a point in that position where we were while it was rotated. So it was -6, 3. So we're going to have a point over here, that's B2 at -6, 3. And so the coordinates there are going to be B2 are the point -6, 3. Okay, so that's what you should get for this one over here. Now the last one, you'll see that when we're finding B3, we haven't been told a direction for this one, and that's because it's 180 degrees. So if we are going to do this one, you can see if you put your finger on the origin and you rotate this 180 degrees in an anti-clockwise direction, you end up with a point over here. But if you also rotate it in a clockwise direction, you're going to end up with it in the exact same position. So that's why when it's a 180 degree rotation, they don't need to tell you the direction because you end up in the same position no matter what the direction. Okay, so when it's 180 degrees, they don't need to give you the direction. Okay, so then just like with the previous ones, we're going to pretend that the axes weren't rotated. And so our axes over here will look like that. So after the point B was rotated, it's now in the position where x is -3 and y is -6. Okay, so now let's go and rotate it back again. We're going to end up with a point that we're going to now place in that same position where x is -3 and y is -6, and it will look like that. So that is the point B3 with the coordinates -3, -6. Okay, so now you're going to do one for yourself. So in this activity, you've got the point A, which has the coordinates -4, 3, and it is being rotated about the origin. You need to write down the coordinates of A1 after rotating A 90 degrees clockwise, the coordinates of A2 after rotating A 90 degrees anti-clockwise, and you need to write down the coordinates of A3 after rotating A 180 degrees. Okay, so I'm going to give you 2 minutes to work on this activity. Okay, so let's go through what you should have got for that. So first of all, you had to plot the point A, which should have been over here at -4, 3. Okay, then if you look at where A is in relation to the origin, which is the center of our rotation, and we go 90 degrees in a clockwise direction from that, you should have ended up with a point over here at 3, 4. So A1 has got the coordinates 3, 4. So that's what you should have got for the first one, where you were rotating 90 degrees in a clockwise direction. And the next one, we're rotating 90 degrees in an anti-clockwise direction. So we're going to go in the opposite direction from A. We're going to go this way, and that is going to look like this. And that'll give us a point over here at -3, -4. So A2 has got the coordinates -3, -4. And then A3, we had to go 180 degrees. Now remember, if we go 180 degrees in this direction or in the other direction, anti-clockwise or clockwise, both ways, we'll end up with the same point, and you should have ended up with a point over here, and that has the coordinates for -3. So that's what we should have got for those points after rotating A in all of those different directions and for those different angles. Okay, so now let's go on to the next one. You're going to do the same thing. This time you've got the point B, -2, -3, and you're going to do the same thing with that point, rotating it 90 degrees clockwise, 90 degrees anti-clockwise, and 180 degrees. And I'm going to give you 2 minutes again to work on this activity. Okay, so let's go through that example. So first you had to plot the point B, -2, -3, so that is over here. Then we had to rotate it 90 degrees in a clockwise direction from the origin. So here's the origin over here. If we go 90 degrees in a clockwise direction, it's going to end up like that. So you should have ended up with a point over here. B1 has the coordinates -3, 2. Okay, then to find B2, you had to rotate it 90 degrees anti-clockwise. So that's going to go in this direction, 90 degrees, and that's going to end up over here, giving us a point 3, -2. So B2 has the coordinates 3, -2, and then the last one, we're rotating 180 degrees. So if we rotate 180 degrees, this direction or this direction will end up with a point over here, which has the coordinates 2, 3. So B3 has the coordinates 2, 3. That you should have got for that activity. And now the last question in this activity, we've got over here point C, which has the coordinates 8, -5. You're going to do all the exact same things with this point over here. So I'm going to give you 2 minutes to work on this question as well. Okay, so let's go through what you should have got for that example. So in this question, you first had to plot the point. So that should be over here, the point 8, -5 over here. Then you had to write down the coordinates of C1 after rotating C 90 degrees clockwise. So first of all, here's the origin. So we've got this over here. If I go 90 degrees clockwise, it's going to go in this direction. And you'll end up with a point over here. So you should have plotted the point C1 over here with the coordinates -5, 8, -8. So the point C1 is -5, -8. Then you had to go 90 degrees anti-clockwise from C. So we're going to take C, we're going to go in the opposite direction now, 90 degrees anti-clockwise, and you should have ended up with a point over here at 5, 8. So the point C2 has the coordinates 5, 8. And then the last one we had to do 180 degrees. So if I go in this direction or if I go in this direction, I will end up with a point over here, C3, and that has the coordinates -8, 5. So that's what you should have got for each of those. Okay, now let's have a look at rotating shapes on the Cartesian plane. So now we're looking at shapes, not just points, but just like when we're doing translations or reflections, when you rotate a shape on the Cartesian plane, all the points in that shape undergo the same rotation. So we can just do it all together. Okay, so over here, our first example, write down the coordinates of A prime, B prime, and C prime if triangle ABC with vertices A, -2, 6, B, -3, 4, and C, 2, 3 is rotated 90 degrees anti-clockwise about the origin. So first thing we need to do is plot the triangle. So we're going to plot the points. A is -2, 6, B is -3, 4, and C is 2, 3, and then join it together as a triangle. So that's what you should get when you plot that triangle. Okay. The next thing we need to do, just like we were doing when we were doing points, is put your finger on the origin, because the origin is the center of our rotation, and we're going to go and we're going to turn this around in the direction that they say. So it's 90 degrees in an anti-clockwise direction. So we're going to go like this, over there, and you're going to end up with something that looks like that. But remember, pretend that the axes didn't move when you rotated the page. So this is still the x-axis, this is still the y-axis, and have a look at where the points are. Now just look at all three of the points. So A is the point -6, -2, B is the point -4, -3, and C is the point -3, 2. So now we're going to go and rotate it back again, and we're going to plot the triangle as we see it over here after the rotation. Okay, so I put it back, and now let's go and plot the triangle as it was after while it was rotated. So we had something that looked like this. So the point A was at -6, -2. The point B was at -4, -3. And the point C was at -3, 2. And that's what you should end up with for this triangle. So when you rotate a shape, you just take the whole thing and you rotate it around the origin, if that is the center of rotation. And then you take note of where each of the points are, and then you turn it back again and you just draw that shape in the place that it was after while it was rotated. Okay, so now I'm going to give you one that you're going to do for yourself. So over here, we've got the triangle PQR with vertices P is -2, 1, Q is 0, 5, and R is 6, 0 on the Cartesian plane. Then you also need to draw triangle P prime, Q prime, R prime, which is the image of triangle PQR after it is rotated 180 degrees about the origin. And then you need to write down the coordinates of P prime, Q prime, and R prime. So I'm going to give you 2 minutes to work on this example. Okay, so let's go through that example. So the first thing you had to do was plot the triangle PQR with these coordinates, and you should have had something that looked like this. So point P is -2, 1, point Q is 0, 5, and point R is 6, 0, giving you a triangle that looks like this. Okay, then you had to draw triangle P prime, Q prime, R prime, which is the image of this triangle after it's been rotated 180 degrees. Now you should have ended up with something that looked like this, where P prime is 2, -1, Q prime is 0, -5, and R prime is -6, 0. Now you have to go and write down the coordinates of those points. So you should have had P prime is the point 2, -1, Q prime is 0, -5, and R prime is -6, 0. Okay, so now let's have a look at area and perimeter. Rectangle ABCD with vertices A, -7, 3, B, -7, -2, C, -4, -2, and D, -4, 3 is rotated 90 degrees clockwise about the origin. First, we need to calculate the perimeter of ABCD and the perimeter of the image of ABCD after the rotation. Then we also need to calculate the area of ABCD and then the area of the image of ABCD after the rotation. Okay, so first we're going to go and plot the rectangle ABCD. Okay, so over here, I've got the point A is -7, 3, B is -7, -2, C is -4, -2, and D is -4, 3. So this is the rectangle ABCD. Now, when you rotate this 90 degrees clockwise, you should end up with something that looks like this over here. Okay, so it's been rotated in a clockwise direction 90 degrees. Now we're going to go and work out the perimeter of each of these shapes. Okay, so first of all, the perimeter of ABCD using the normal perimeter formula, 2 lengths plus 2 breadths. So the length of ABCD is 5 units and the breadth is 3 units. So I have over here 2 times 5 plus 2 times 3, that gives me 10 plus 6, which is 16 units. So the perimeter of ABCD is 16 units. Now let's work out the perimeter of the image of ABCD after the rotation. So again, I'm going to use my perimeter formula, and I've got over here, the length is also 5, just like it was over there. So I've got 2 times 5. And then the breadth is also 3, just like it was over here. So I've got 2 times 3. That gives me 10 plus 6, which is 16 as well. So 16 units. So both of them have got a perimeter of 16 units. Now let's have a look at the area of the two rectangles. So to work out area, I use the formula area is length times breadth. So for my ABCD, I've got a length of 5 and a breadth of 3. So that's 5 times 3, which gives me 15 square units. So the area of ABCD is 15 square units, and then the area of the image of ABCD, I'm going to do the same formula. The length is also 5, the breadth is also 3, so that gives me 5 times 3, just like I had over there, and that gives me 15 square units as well. So the area of both rectangles is the same, the area of the original rectangle and the image of ABCD after the rotation. So when you are rotating a shape, when a shape is rotated, the size and shape do not change. The image is congruent to the original shape. Remember, congruent means that it's the exact same shape. It has the same size, it has the same shape. It can be in a different position, but the size and shape do not change. Okay? This means that the area and perimeter of the image are the same as the area and perimeter of the original figure. Now let's have a look at the rules for rotations. Okay, so now we've learned how to do rotations by putting your finger on the origin and turning the page, but it is helpful to know how to work out the coordinates of points after a rotation without having to actually physically do that. Okay, so let's have a look at the rules that we can get for rotating a point about the origin. So if point T is rotated about the origin 90 degrees clockwise, let's have a look and see what we will end up with for a rule for this. So if we're starting with point T, which is the coordinates x, y, so x can be anything, y can be anything. We want something that will help us to know what to do to work out what the coordinates will be after the rotation. So let's have a look at the examples we've done in this lesson. So the first example we had, point B was the point 3, 6. When it was rotated 90 degrees clockwise, it changed to 6 minus 3. Okay, so you can see the 3 and the 6 switched places, but the 3 had changed to negative. Okay, so let's have a look at the next example we did. When we had the point A, negative 4, 3, it changed, when it was rotated 90 degrees clockwise, it changed to 3, 4. So again, the 3 and the 4 changed places, and the negative 4 became positive. Okay, so now let's have a look at the next one. When I had point B, negative 2, negative 3, and I rotated it 90 degrees clockwise, I ended up with negative 3, 2. So the negative 2 changed to positive 2, and they switched places, giving me negative 3, 2. And then when I had the point C, 8, negative 5, the exact same thing happened. The 8 changed sign, it became negative, and they switched places when I rotated it in 90 degrees in a clockwise direction. So a rule that we can have when we are rotating a point 90 degrees in a clockwise direction is that the x value is going to change sign, and they will switch places. So to change the x value sign, I multiply it by negative 1. So it's going to be negative x, and they switch places. So it becomes y negative x. Now let's have a look at when we rotate a point 90 degrees anti-clockwise. So again, if t is starting as xy, whatever x is, whatever y is, let's see what our rule is going to be. So looking back at the examples we did before, again, when b was 3, 6, and we rotated 90 degrees anti-clockwise, the 6 and the 3, or the 3 and the 6, also switched places, but the 6 became negative, so it changed sign. Okay, now let's have a look at the next example. I had a was negative 4, 3, and when I rotated it 90 degrees anti-clockwise, it became negative 3, 4. So the negative 4 stayed negative 4, and it switched places with the y value, and the 3 changed to negative 3, and it switched places with the x value. Now let's have a look at the next one. We had b, negative 2, negative 3. When I rotated it 90 degrees anti-clockwise, same thing happened again. They switched places, but the y value changed sign. So y became changed from negative 3 to 3, and they switched places, giving us 3, negative 2. And then the last one we did, C was the point 8, negative 5. When we rotated it 90 degrees in an anti-clockwise direction, then the y value changed sign, became positive, and they switched places, giving us 5, 8. Okay, so our rule, when we are rotating a point 90 degrees anti-clockwise, the point changes from x, y. The y value is going to change sign. It's going to be either, if it's positive, it becomes negative. If it's negative, it becomes positive, which means we are going to have negative y, and they also switch places. So it's going to be negative y, x. Okay, so that's our rule for if you are rotating it 90 degrees anti-clockwise about the origin. Now let's have a look at when we rotate it 180 degrees. Now remember, for 180 degrees, the direction doesn't matter, because no matter which direction you work with, it's going to give you the same point either way. Okay, so again, I'm starting off with t, which has the coordinates x, y. We want to know what our rule is going to be. So let's have a look at our examples. So in the first example, we had b, which was the point 3, 6. When we rotated it 180 degrees, we ended up with b, 3 being negative 3, negative 6. So they stayed in the same places, and they both changed sign. They both became negative in this one. The next example, a was negative 4, 3. When we rotated 180 degrees, it became 4, negative 3. So they both changed sign. If it was negative, it became positive. If it was positive, it became negative. The next one, we had the point B, negative 2, negative 3. When we rotated 180 degrees, it became 2, 3. So they both changed from negative to positive in this one. And in the last one, we had C was 8, negative 5. When we rotated 180 degrees, it became negative 8, 5. So again, the positive one changed to negative, and the negative one changed to positive. So our rule for when we're rotating a point 180 degrees is that the x and y values will both change sign. They don't switch places, but they both change sign. So x becomes negative and y becomes negative if they are starting off as positive. But if they're starting off as negative, they will change to positive because they are being multiplied by negative 1. So it's negative x, negative y, this meaning that they are changing sign. And that is how we rotate points and shapes on the Cartesian plane in transformation geometry. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.